And then the definition of dependent events: two events are dependent if the result of the first event affects the result of the second event. The probability that both events will occur is the product of the probability of x and the probability of y given that x has occurred. So one way to look at this is the probability of x. The probability of x followed by y occurring after x occurred is equal to the probability of x multiplied by the probability of y given that x has occurred. And the last couple examples show you how to calculate that. We're going to practice with this worksheet, which is helpful because it's considered self-assessing. In other words, if you find the probability at the bottom here, you probably have the correct answer. But if you don't find it, you certainly do not have the correct answer. And so it gives you a chance to go back and double check your work. I'm going to go through all of these, but you should have tried them on your own first. So these first four, either pause the video or I probably would have had them on a draw it slide. You can go back to that slide and work them on the screen if you like doing that. But in any case, problem 1, the probability of black then white is equal to the probability of black multiplied by the probability of white after black. And so the probability of pulling a black card, there are 1, 2, 3, 4, 5 of the 8 cards are black. And when you go to calculate the probability of white after black, I don't see any way to avoid. I'm going to show you, how do I do this? What you should do on your paper is use your thumb to cover up a single black card. Here, I'll draw a thumb. Use your thumb to cover up one black card so that you can then just focus on what's left. But don't draw on it like I'm doing because the cards reset for the next problem. So really you just want to use your thumb to cover up a single black card. One black card's been pulled and it doesn't matter which one. Then when you calculate white after black, there are 3 white cards out of not 8 anymore, because remember we took that black card out and we didn't replace it. So there's 3 white cards out of the remaining 7 cards. So you're multiplying by 3/7. Then you should look at your numerators and denominators for common factors. However, there are none in this case. So 15/56 is the correct probability for problem number 1. And there are 2 of them at the bottom of the paper. You can cross out your favorite one. It doesn't matter which one. Don't cross them both out. I'm going to use colors to my advantage. First I'm going to erase that. Now if you're just covering one with your thumb like I recommended, there'd be no reason to erase anything. Probability of number 2 is probability of black then black. So this probability of black multiplied by the probability of black after black. The probability of black we already calculated in the first problem is 5/8. But now you've got your thumb covering up one of the black cards, it doesn't matter which one. The probability of pulling a black card now, of the 7 remaining cards, 4 of them are black. So 4/7. And here I do have a way to simplify before I multiply because 4 and 8 both have a common factor of 4. 4 divided by 4 is 1, 8 divided by 4 is 2. And so we get 5/14. Now if you didn't simplify first, you would get 20/56, and you're not going to find 20/56 down here, but that doesn't mean you're wrong, it just means it's not in simplest form. So if you're not finding it, consider first whether you simplified all the way. If you convince yourself that you have, then maybe there's an error in the computation, but I see 5/14 here, so I'm crossing it out. I'm wondering if there's going to be a way for me to, yeah, I could do this. Okay. Now all you have to do is lift your thumb. I have to erase this to make things clear. And number 3, probability of white, then black. So multiply by probability of black after white. Probability of a white card is, there's 3 white cards of the 8 cards. So 3/8. Now I'm covering up one white card with my thumb. And then I want a black card now. There's 5 cards. 5 of the 7 cards are black. So 5/7. There are no common factors in any numerator and denominator. In fact, this is just another version of this, really. So we get 15/56 again. So we'll cross out the other 15/56. Doing number 4 now. Number 4 says probability of white, then white, so white after white. The probability of a white card is 3/8. But then if I don't replace it, so pretend you're covering that one up, there's 2 left of the 7 remaining cards. So multiply by 2/7. The 2 and the 8 have a common factor of 2. This becomes a 1 and this becomes a 4. So in simplest form, it's 3/28. That probability is 3/28. This is one of the puzzles where you don't write the letters down until after you've found all the correct answers and crossed out all the correct answers. I'm going to cross them out first. Now I'm forgetting what no, there it is. These 2, of course. All right. That's interesting. Why would I have 2 slides for that? I'm sure I had a reason.